All right, guys, we are going to go over 5.6. It's one of the last two lessons out of this unit, and we're going to be stepping back just for today with having two equations. We're going to go back to one, but instead of equations, we're going to talk about inequalities. We graphed inequalities on number lines before, where we had our number line, and let's just say x was greater than 2. So on our number line at 2, we would put a circle, and it would stay open because it wasn't equal to, and since it's greater than, we would shade to the right. Okay, so that's what we have done so far with graphing inequalities, but now instead of just one variable, we'll have two. We'll have the x and the y. Okay, so let me clear that off. All right. So in order to graph linear inequalities, there's 4 rules that we have to remember. The first rule is all about the line and what the line looks like. The second rule is all about the shading and what will happen according to our inequality symbol that we have. If our inequality sign is greater than or less than, our line is going to be dashed. So it's not going to be connected. That's because this line is just a boundary. Anything on this line is not going to be a solution. It's just kind of telling us where we start or where we stop. If our inequality sign has the or equal to, so greater than or equal to or less than or equal to, it's going to be a solid line because we're going to include all the points on this line for our solutions. Shading, we strictly look at whether it's greater than or less than. So these are both greater than symbols. So if it's greater than or equal to, we're going to shade above the line, so on top of the line. If it's a less than symbol, so less than or equal to, we're going to shade below the line. Sometimes students have a hard time determining if it's above or below because the line is so steep. I always tell my students, draw a person walking on the line, because you're going to draw them on the top. So if you're supposed to shade above this line, you would shade where the person was. If you're supposed to shade below the line, you shade where the person isn't. So that's just a little trick that I've come up with along the years of teaching this. Okay, so very important. You have to know your inequality sign and what it means for the line. Know your inequality sign and what it means for the shading. Because what happens is the shading tells us the solution. So let's jump into some practice. We want to be able to tell whether the ordered pair is a solution for the inequality they give us. So remember, this colon sign right here, semicolon, that's just breaking apart. This is the inequality, this is the solution we're trying to check. That doesn't have any mathematical value to it. It's just separating the two things in this sentence. Okay, so in that ordered pair, 3, 2, we must remember that x is the first number and y is the second. So it's telling us, can I take this 3 and put it in for this x and this y and put it in for this 2, work this out, and is it true according to what that inequality sign says? So 3 plus 2, is that greater than 5? Well, what is 3 plus 2? It's 5. Is 5 greater than 5? No, it's not. So no, this isn't a solution. If it were a solution, we would have ended up with something true at the end. Okay, so let's look at number 2. X minus y is greater than or equal to 2. They want us to try the 5 and the 3. So we're going to put 5 in for the x and 3 in for the y. 5 minus 3, is that greater than or equal to 2? So again, I'm going to work it out on the left side. 5 minus 3 is a 2. Then I bring down greater than or equal to 2. So is 2 greater than or equal to 2? Some say yes and some say no. Those of you that say no, you feel like it has to satisfy both of these things. It has to be greater than and it has to be equal to. Well, that's not possible. It just needs to satisfy one. Is it greater than 2? No. But is 2 equal to 2? Yes. So since it is equal, this would be a yes. 5, 3 is the solution. Okay, so why don't you go ahead and pause the video and try out example 3 and see how you do. Okay, so I'm going to go through it quickly. I'm going to put in my -2 for x and my -3 for the y. This is where we get mixed up. This negative sign in front of the x isn't the same as this negative that's with the -2, so be careful there. So we have a negative times a -2, and then a -2 times a -3. All I did was replace the y. That -2 stayed the same. So -2 times negative gives me a +2. -2 times a -3 gives me a +6. Now is that greater than or equal to 5? So 2 plus 6 gives me 8. 8 is greater than 5. So yes, this is a solution. How'd you do? Okay, now let's look at graphing some inequalities. So these first two, y is less than 4 and x is greater than 3, are special linear functions because they only have one variable. So y is less than 4. We need to figure out our slope and our y-intercept. Our slope is paired with an x. I don't see an x. So if there's not an x, our slope is 0. Because 0x would just be 0. Your b value is your number that is not attached to the x. So in this case, it would be the 4. So now I'm going to graph. Remember, we begin our graph at b. Begin at b. b is the y-intercept of 4. So on the y-axis at 4, I'm going to put a point. We begin at 4 and then we move according to our slope. Our slope tells me that I'm not moving. Y is going to stay a 4. So what happens is all of these points to the left and to the right are going to guide this horizontal line because all of these y values are 4. If you move up or down at all, your y value is no longer 4, and 4 is all you have. Now it comes to this dashed line. I know it's dashed because my inequality sign is just a less than. It's not equal to. So I'm going to have this dashed line. Next, I need to shade. So again, I'm looking at my inequality sign. It says less than 4. Less than means we're going to shade below this line. So everything below that line gets shaded. So this graph tells me anything under this line is a solution to this inequality, but not what's on the line, just anything below it. Number 5, all we have is an x. So when we're talking about m and b, we have a little bit of a different situation because we don't have a y-intercept that we can quickly pick out, and we don't have the slope because we're not in slope-intercept form. So we have to remember that if we have just an x, this is going to create a vertical line. When we have just a y, that creates a horizontal line. Okay, that's from chapter 4. We learned that in. So next, I know I'm going to have a vertical line, and I'm going to have it at the x equals 3. So I can put a point at x equals 3, so right here on my x-axis. Then I know I'm going to go up and down from this point to create my vertical line, but am I going to have a solid or dashed line? This inequality sign tells me I'm going to have a dashed line because it's not equal to, it's just greater than. So I'm going to create my dashed line. Then with vertical lines, this is the trickiest part, is the shading, because is there an above line and a below this line? Well, no, because it is going up and down, straight up and down. We have to the left and to the right. That's what we have. So x is greater than 3. So think about it. Is 2, 1, 0, -1, -2, are all of those greater than 3? Or is 4, 5, 6, 7, those greater than 3? Well, the ones to the right are greater. So we're going to shade to the right. So those are our special circumstances when we have that horizontal and that vertical line. Next, on number 6, we're going to graph this because it is in slope-intercept form. So we can just go straight to graphing this.